Okay, today the goal is to present you ORDS running in a Kubernetes environment, and so running on OCI OKE. This is the Kubernetes managed cluster on Oracle Cloud. First, I created a Docker image. I followed the documentation here, and I installed ORDS in order to reach a database, an autonomous database on the cloud, a HTTP, here, HTTP. I deployed the image on the Oracle Cloud registry. The image is here. And after that, I deployed the image on a Kubernetes cluster. This Kubernetes cluster here has a node pool with 3 VM. Okay, 3 VM here. The deployment is very simple. It was done using a YAML file. First, the deployment of the image, then the deployment of the service in order to create a load balancer in front of the pod running ORDS. And if I want, I can create an horizontal autoscaler and a cluster autoscaler in order to scale on ORDS. But this is not the goal of the presentation, as I have already done a video concerning these autoscalers on OKE. Everything is ready. As you can see, I have 2 ORDS that are running, and I have a load balancer in front of the ORDS. I can reach here ORDS. I use a URL Vanity OKE example in order to mask the public IP. And personally, I'm using a security with OAuth, so I use this OAuth token. You can see it because in a few moments it will not be okay to use it. Okay. I send, I get the list of the employee in the table employee, and for the moment I have 14 employees in the table employees. The goal is to do a mini bench and to do insert and to see what happens, what will happen. To do that, I am going to use K6. This is a new load runner from Grafana. Super nice. As you can see, I have 3 stages. First stage, this is ramp up in order to get 120 users. Okay. After that, I will have 130 users during 15 minutes and a ramp down during 1 minute in order to reach 0. Okay, let's go. I'm going to run K6 here to do the load test, and so I will run. It's okay, it started. As you see, this is the ramp up period, 14, 15, up to 120. I will come back in a few minutes when the load bench will be finished. See you in a few minutes. Okay, the test is finished. So, what is the result? I can see that I created more than 1,700,000 employees in the autonomous DB. And I reach a throughput of 1,600 inserts per second. Wow, nice. Just if I have a look to the DB, concerning the sizing, we have 4 CPU and it's okay. Okay, we see a big number of server requests. If I have a look on a VM from the node pool, oh, I see that the VM was used near 100%. It means probably I need to have bigger VM and I can give more resources concerning CPU to ORDS. Concerning the two ORDS, what we can see is during the bench, they use near 4 vCPU. It means this is near the maximum concerning the VM in the node pool, because the VM in the node pool has 2 OCPU. It means 4 vCPU for a maximum, knowing that other pods are running on this VM, like pods in the kube system, and so on and so on. Okay? So at the end, a very nice result. I have a read here on HTTP reg duration because I put a checker and I wanted the percentile under 200 milliseconds, but I got 222 milliseconds. It's quite interesting to see that the medium time for this insert in the table employee is 46 or 47 milliseconds, but the percentile 95, it's over 200 milliseconds. Probably I need to add another ORDS, or I need to increase CPU or memory used by the two ORDS. With this architecture, what is very, very nice, if I want to increase the number of ORDS, I can just go to the deployment and increase the number of replicas. Or I can use the horizontal autoscaler of Kubernetes plus the cluster autoscaler of Kubernetes. Knowing that I can scale for ORDS on Kubernetes, it's very nice, but knowing that I can scale too on ATP because autoscaling is enabled. Sure, I didn't see an autoscaling here because we see that the CPU utilization is not so high. Okay, so super nice architecture with high availability on ORDS, autoscaling on all the components of the architecture. Thank you for your attention.